Right, this is how we mark up a cube for turning into a dodecahedron. I've drawn a face of my cube. You can do this straight on your cube, or you can do it on paper and then transfer the measurements to your cube. And how I've done this one is I used the 1, 2, 3 block, and I used the 1, 2, 3 block to set my table saw to 50 millimeters. This is 50 millimeters by 100 by 25. Not really a 1, 2, 3 block. Got a tiny bit of rust there. I'll have to get that off. Anyway, so I used that on the drawing board to draw this, so it's to exact scale. Anyway, that doesn't really matter. It's getting this measurements down. So I've drawn the face of the cube, and I've divided it into 4 quadrants. And now we need, right, to multiply the length of one of the sides of the cube, which is 50 millimeters in our case, by 1 over 5 squared, which is 0.391965, which works out at 19.598. And I've got this compass set at half of that, or 9.8, or thereabouts, and we need to put some marks here. Mark it, that distance out from the top and the bottom. Oops. And also from the centres, mark it on the centres of the, out from the centre of the cube, just on those lines. Now I did a video to get that exact geometrically, but I can't get that video down to under 20 minutes, so it's going to have to, I'll release that video when I've got 1,000 subscribers, because I can't release a video over 15 minutes until then. Anyway, so what we want to do now is just get a straight edge. We're going to draw that line there, and that's that distance, you know, that is 19.6 ish. You'll be very close to being exact anyway. The inaccuracies will just be fractions of a millimetre, like a tenth or so, maybe 2/10 of a millimetre. And then we want to go from these points to the centres to create these shapes. Okay, and we've got to mark up every face of the cube exactly like that. Now, what you end up, but the orientation matters. So I'm calling this the x-axis, this the y-axis going back, and this the z-axis going up and down. So each axis points at the centre of the next axis, so they're all at 90 degrees to each other, so you've got your x, y and z planes, if you like, cutting through the cube. So that orientation there, it should look like that, you know, every one that points at the centre of the next one. Anyway, so next step is what we're removing. There are 12 of these wedges created by this marking out, Oh, the opposite side is the same orientation as this, and the opposite of that, same as that, opposite of that, same as that. So we've got 1, 2, 3, 4 on each face, which is on each axis, sorry. So 5, 6, 7, 8, 9, 10, 11, 12 wedges that we've got to remove from that cube. Now something else, just very briefly, is that angle, if we measure it, well, we don't have to measure it, it's the it's 58.3 degrees, that angle, and that's the 180 degrees minus the dihedral angle of a dodecahedron. And again, we've really, if you drew all this out geometrically, that is the right angle, and that's what that angle is. So we have to remove the 12 wedges, but as you remove one wedge there, look, you're gonna destroy the marking out on this. So you remark that, and you remark it using the lines of the next adjacent axis, if you see what I mean. So what happens is that the angles of the lines changes as it goes back onto the next face, as the meeting point. It changes the angle anyway until it's right, as you do these. But that 58.3 is always the same. It's just, it makes it easier to visualise by keep remarking it. You could do it without remarking it if you've got a really good mind for capturing that and remembering that geometry. So you can do this by turning, or you could use a table saw, or some combination of different things. However you do it, you could plane it off, or whatever you want to do. But remove all of those 12 wedges and you end up with your dodecahedron, which is exactly what I did to make this one, and it's a pretty good dodecahedron. Okay, thanks for watching.